You are going to solve these equations, and to do that, the variable currently is being divided. So to undo division, we're going to multiply by the denominator to get the x by itself. So then I have x equals, well, 5 times 42, you can think of it as 42 over 1. That way it helps you remember that the denominator is going to be a 6. And the numerator should say 210. Now you can simplify that. 210 can be divided by 6 and it gives you 35. Go ahead and complete the remaining problems. Some of them will still be fractions. Others may come out to whole numbers like we saw in problem 4. What strategies could you use to find the height of the rectangle? Well, the nice thing is we see here that there are angles that match up from the 3 different triangles. We also see that they all have a right angle. So by AA criterion, we know these are similar. And because they are similar, they have side lengths that all use the same ratio. So this side length from the big triangle matches up with, this is directly across from the right angle. So directly across from the right angle here, we have this side length. And the side between the right angle and the one with 2 marks on the largest triangle matches up with the one between the right angle and the 2 marks here. So we can pair these together. My students like to put the big number on the top of the fraction and then the one from the smaller triangle underneath. And so the big one from here matches with 25, and then the one from the smaller triangle is 20. We use a strategy called cross multiplying. So 25 times x is 25x. And then we also do 15 times 20 on the other side of our equal sign. Well, 15 times 2 would be 30, but since it's times 20, it's 300. Then we can divide both sides by 25 and solve that for x. If we divide 300 by 25, we get a height of 12. The nice thing about this problem is it tells us they are similar. So we don't even have to worry about showing AA criterion works here. We already know these two triangles are similar. It asks for the length of EA. So we have to use the side lengths that match up from both triangles. So I have this long side length here, which matches up with this little side length here. I have this long side length here from the big one that matches up with this piece from the little one. So like I said, my students like to put those big ones on top and the small ones on the bottom. Cross multiply. 2 times 15 is 30. 5 times x is 5x. Divide by 5 on both sides. So x equals 6, and that is the side length of EA. If DE is 17.1, What is the length of BC? We can use the same set of values here, 15 and 5, and 17.1, and this unknown here we can label with y. Cross multiplying, I get 15y, and 17.1 multiplied by 5 gives us 85.5. Divide both sides by 15. And that gives us y is 5.7, which is BC. So this is just showing you that all of the side lengths paired up create that same scale factor r. And when I say same side lengths, I'm talking about ones that are corresponding to each other, ones that get paired together. In this diagram, again, we're provided that they are similar. So find the lengths of AN and AE. This one gets paired up with this side. This one gets paired up with this side. And this one gets paired up with this side. So I have AE is an unknown distance here, but it is the same, corresponds with 11.4. Then I have 9 and 6. I'm going to use the 9 and the 6 to help with finding AN as well. The big one here for the orange is 18.3, and the small one is unknown. Again, we can use the letter y. We're going to cross multiply. This gives us 6x, and 11.4 times 9 is 102.6. Divide both sides by 6. And that gives us 17.1. So AE is 17.1. Cross multiply, 6 times 18.3 is 109.8. And 9 times y is 9y. Divide both sides by 9. And y is 12.2, which is AN. A user pinches the touch screen of a tablet computer to reduce the size of a full screen picture. The diagram shows the full screen and the reduced picture, which are similar figures. Find the screen length of the tablet computer in inches. So here, this one corresponds with this side length. We have 7 and 1.75. And then this one corresponds with, this side length. So that is the unknown and 2.4. Cross multiply 1.75x. And 7 times 2.4 is 16.8. Divide both sides by 1.75. And x is 9.6. Don't forget the units on this one. If they provide them to you, make sure you include them in your answer. In the diagram, ELK is similar to HUG, and HUG is similar to WIN. Find all the unknown lengths of the triangles. We have the 12, 13, and the unknown here, which we will label X. This gets paired up with this side length here, this one here, and this one. Then we also have it is similar to here, here, and here. So all the green ones are corresponding, all the blue ones are corresponding, and then the pink and the red match up as well. So we're going to set the fractions equal to each other. So we have 12 and 9 go together. So then the 13, and we'll label this one y, go together. We'll cross multiply and divide. That gives us 12y. 9 times 13 divide by 12. So this one here, HG is 9.75. We compare the green ones together again to help us find the pink pieces. I have an X and a 13.5. Cross multiply gives me 9x. And then we've got to do 12 times 13.5. Divide by 9. And x equals 18. So that helps us with the large triangle and the medium triangle. Now we just have to solve for the small. So I have a 13.5 is paired with this one down here. We can label it M. And we have a 9 and a 6.75. Cross multiply. And we have our blues that can be paired together. I have a 9.75, and we can label this Q. And those get paired up with the 9 and the 6.5. Also are in the medium and the small triangle. Or sorry, 6.75. Cross multiply. Divide by 9. And Q equals 7.3125. Find the length of ET. Well, first we have to determine if they are similar. So to find this missing angle here, I can subtract from 180. I have an angle that's 39 and an angle that is 18. When I subtract those, I do get 123. So they are similar by AA criterion. So now I can solve for ET. Let's label that side here with X. I have a side length that is 3.3 to pair with a side length that is 6.6. And then I need a side length that matches up with this angle here for X. Sorry, this side length here for X. So I have a 5 and an X. Cross multiply. Divide by 6.6. So ET is 2.5. So there are a couple of different ways we can determine if triangles are similar, and then using this similarity to help us find those missing side lengths. One of the ways we can determine if they are similar is through AA criterion, where we use those two sets of equivalent angles from each figure or each triangle specifically. And the other way is using a sequence of rigid motions or dilations that map one to another. So if it can be dilated and shifted or reflected or rotated to match up, then that's another way you can prove that they are similar. So here, it doesn't tell us that they are similar, but it does give us these little arrow indicators which say that these lines are parallel. So since these lines are parallel to each other, and we have a transversal or two cutting through them, we can say that there are angles that are corresponding or alternate interior or alternate exterior that would tell us these angles are the same. So here I know that this angle and this angle are equivalent because they are alternate interior angles and the lines are parallel. I also know that this line is a transversal between the two parallel lines. So this angle and this angle are alternate interior. Since I have two pairs of equivalent angles inside of my triangles, I know the triangles are similar. So we have alternate interior angles. So the triangles are similar using that AA criterion. Now that we know they are similar, we can start talking about their side lengths. So I have this side length here, which is going to match up with this side length here. That's EK, the one I'm trying to find. So I'm going to put the variable there. And then I also have that this side length matches up with this side length. So I can set up that fraction. And this one. Then cross multiply. This would give me 4x. And then we need 5.1 times 6, which is 30.6. Divide both sides by 4, which is 7.65 for this EK side length. Problem 8 asks us to find the height of the rectangle, which we already did in problem 1. Back in problem 1, we were just trying to think of strategies, but we already solved it. So you can just mark off that you've completed it in problem 1, or you can rewrite the work we did in problem 1 here in problem 8. Check back in for lesson 15 shortly.